topic semantic network, which is a form of representing knowledge. So you have learned already various other methods to represent the knowledge in the system. Okay. So what are all the ways we have discussed already or studied? First order logic, propositional logic. Super. So those two are the methods you have learned already. Right? So the third way to represent the knowledge in the system is semantic network. Now the question is, why the knowledge has to be represented in the system? What is the necessity? Why we should go for various methods to represent the knowledge? See, our objective from the system is my artificial intelligence. My system should act like me, right? Whatever the human being thinks, whatever the decision I take, like that my system also should do. Okay? So you are walking somewhere, you are seeing some, hurdles over there, like you are seeing some pit or you are seeing some dangerous insects or snakes you are seeing. Immediately you do some reaction for that. You will run away from that place, or you will scream like anything, you will shout, or you will call somebody for your help. Something we are doing. We are responding according to the situation. Right? Similarly, whatever the situation is there, my system has to respond accordingly. How it can respond? It must have knowledge. Right? So I have to induce the knowledge to my system. Okay, I have to give intelligence to the system. How am I giving the intelligence to the system? There are various ways. Okay, so few things we have discussed already, which is of logical part. Okay, whereas this is about completely how our human thinks. In the same way, I want to represent. Okay, so normally you are not very good at English. You are very good at Tamil or your mother tongue. Anything you think, the creation will happen in your mother tongue, right? Later, immediately, conversion will be taken place. So the fluency depends upon how fast the conversion is taken place. Am I right that some people may take longer time to convert Tamil to English, so that my fluency will go down. It will be very, very slow. But some people, the conversion process from Tamil to English will be taken so fast, so that I will be able to speak so fluently, very fast manner I will be able to speak. Correct? So, however, I think in the same way, if I am allowed to represent, it comes in Tamil only. If I am allowed to speak in Tamil itself, I will be very good. That is a problem with many people. When I am asking somebody to present something on the dais, they will hesitate. They will immediately ask, "When should I explain in Tamil?" Because that comes so easily for them. Okay, whatever your brain creates, I am able to represent if it is my comfort or convenient language. Okay, so here you are learned various logical thing and all. But now simply, as it is, I am allowed to represent in the system, and that is how my semantic network comes into existence. When I say somebody, Mithun is sleeping, that is a statement I want to say. Okay, so I am allowed to use some pictorial representation. Easily I can represent it. Okay, whatever comes to my mind, I don't apply any algorithm over there. I don't apply any inference engine, any logic, nothing I do it. Okay, however it comes, I am able to represent. So that is where semantic network comes into existence for the representation of knowledge. Okay, there are various techniques to represent the knowledge, but one among the techniques is semantic network. So how do I represent the knowledge using semantic network? Semantic network is a graphical model. So when I say graph, it is comprised of nodes and edges. Nodes and edges. Of course, we will be using nodes and edges to represent the knowledge in the system. That is what is semantic network. Now you can look at this slide. Semantic network is a graphical model used to represent the knowledge in terms of nodes and edges, where nodes represent the entities. Okay, so I am talking about the entire class. So the class is having some of who are good at Aiml, who are good at AR, something like that. Okay, I have set of courses, I have set of students, I am establishing a relationship among them. I have some, handful of projects and I am choosing some number of students for the project. So I am just linking the project with the student. I am giving a relationship among this side a group of entities, this side another group of entities. I am establishing a relationship. So what you need to understand here is entities are the basic building blocks. So entities are all the characters in your network, objects in your network, or anything. Everything are called entities. Okay. Suppose you consider a hospital management system where doctors will be entities, patients will be entities, nurse will be entities, and various department will be the entities. Everything are entities. Then you will be giving a link between the entities. Doctor to nurse, or particular doctor to patient, or that particular patient to a particular technology or whatever the disease they are having. For that, what kind of test has to be taken place? You will be establishing a relationship. Okay. So what you need to understand here about the semantic network is there will be a lot of entities. Each one will be a character or an object or a domain, or it may be something. Okay, which will be connected to edges. The edges could be labeled. How do I label it? Now I said that Monisha is a student of Cse&It department. Monisha is a student of Cse&It department. So here Monisha is one entity. Cse&It department is another entity. Is the relationship. So I am connecting both of them. I say Cse&It is a student of ECE department. Cse&It is a student. ECE department is a entity. Both are entities. I am connecting both of them. Lata is the faculty of Cse&It department. Those two are connected. Now Lata is handling the class for Cse&It as well as ECE. Like whatever comes to my mind, I am able to represent it using nodes and edges. And the edges could be labeled as is part of something like that, as something. Okay, so you can give a relationship with some label, and the node also can be labeled. There is a sample example over here. Look at the slide. Tom is a cat. So Tom is an entity, cat is an entity. I have given a connection between Tom and cat with a label is a. It's clear? So the relationship between Tom and cat is there with a label is a, which means Tom is an instance of cat, or Tom is inherited from cat, or Tom is a family of cat. Can be of any meaning. எனக்கு அப்படி சொல்லணும். So I have used is or I can say instance of, or however it can be a meaningful one, I can use it. So from the entire thing, there are so many statements can be generated. Tom is colored ginger. Tom is owned by John. John caught bird. Bird is an animal. Mammal is an animal. Cat is an animal. Cat is a mammal. Mammal has fur. Mammal is an animal. Cat sat on a mat. Cat likes screaming. These are all the statements I am able to generate from the graph. Coming to the real time example, we are all using ChatGPT, right? So you ask you are giving some prompt and you are requesting your ChatGPT to provide some information. The moment you ask, it is giving all related information. Then your request is getting changed. So much is there, but I want only 4 lines of information. Information must be covered, and at the same time it should be very short. I don't have any time to read everything and summarize in a 4 lines. So I am asking the ChatGPT again, give me the same information with only 4 lines. That also it will do. Okay, so it will pick up all the related things and then it will be giving you as per your requirement. First you are giving a request. Okay, you are asking about court movie. Okay, so it will give you information about the actor, actress, director, producer, all those information it will give you. How it gives. So everything is given in the form of a network. It is able to form a statement and give you. Then you are asking another request. What are the movies acted by Vijay? movies connection. Vijay to what are the movies Vijay has acted. So it has a connection among them and collect, make this statement and give you as a information. Okay. So from the network, from the semantic network, it will be able to form a sentence and then give you. Or in your mind, it is in the form of a statement that will be converted as a network when you are giving feeding to the system. Either way, you must know. When you are constructing, it is generated in the form of a statement. ஏன்னா நம்ம எப்படி நினைக்கிறோமோ அப்படியே சிஸ்டம் நினைக்கணும்ன்றது தான் என்னோட அப்ஜெக்டிவ். கரெக்ட்டா? So whatever comes to my mind, I am making it as a network and feeding it to the system. And from the system, what I am expecting, it should be in the form of the way which I can understand. Clear? Fine. There are various components, nodes, ages, labels, project. This is the simplest topic here. Practical also will be very, very simple. Okay? So the various components of semantic network will be nodes, ages, labels and properties. Properties is optional here. Nodes, each and every entity is represented by a node. Okay? So cat, cream in the previous example. So cat and cream are the nodes and I am giving a label as cat lights. Okay, next cat animal. Animal is another node. So I am giving a relationship among cat and animal. Okay, and I am using a relation called insert. So however you want to make your system to understand, you can give that as a label. Okay, right. So each and every entity is represented by a node. Represent entities, concepts or objects. Whoever comes into that. Suppose I am talking about one dictionary, English dictionary. So there each and every words will be the entities. Words and meaning. I have word one entity, meaning another entity. So I give a connection. So for one word, if there are so many meanings, that word could be connected to all the other meanings, maybe of synonyms. Okay. Or if I am going to represent about the antonyms, so all the antonyms will be listed out. This word can be connected to all of them. Okay. So since semantic network is available only when you are using your Gmail and all, when you are typing some word, the rest of the words will come automatically. It will have some relationship, like when you are ending up your letter writing with regards you want to give, with the knowledge regards வரும். Because it is connected with so many other words, but regards is suitable over there. Similarly, thanking, THAN போடும்போதே thanking you வரும். Because it knows that there is a connection between, there is an edge between thanking and you. Clear? Fine. Edges represent the relationship between the nodes. So I have two nodes and the relationship is established with the help of a edge. And labels are optional, but if you give a label only, it will become a meaningful one. So we use labels. Properties, somewhere I will be using cat is a mammal, and somewhere I have used cat as fur. So fur is an entity, cat is an entity. Here it is not inherited from this, it is not part of this, it has this. Whenever I want to include some attributes or properties for one entity, I can go in adding properties to that entity too. Okay, so these four are the elements or the components of the semantic network. And when we think about the relationship, there are three major types of relationship. There are some more types also. They are all part of this only, but majorly it is classified as three types: inheritance, part or whole relation, part to whole relationship, association. Normally part of only we will be using. Inheritance, whenever one entity is inherited from other entity, that is cat is a family, Tom is a cat, which means Tom is inherited from cat, or Tom is a family of cat. Okay, John is a person or human being. Human being is a living being. So human being is inherited from living being. John is inherited from human being. Is an instance of that particular. You are much familiar with your object ஒரு major class from that the other thing are inherited. ரொம்ப difficult அதை பார்க்க தேவை கிடையாது. So how we generate the statement from our mind. So normally when you look at a person is a human being. A person, யாராவது somebody, Karthikeyan or whoever it may be, we say he is a human being. Okay, and all human beings are living being. But living being has so many other categories. Correct? So human being is one of the living being. Clear? So either can be one of the type and part or whole relationship. So when I deal about the project, the project is comprised of some 5 modules. Okay? So module 1 is a part of so-and-so project. Module 2 is the project part of so-and-so project. Something like that. Okay? Similarly, when we talk about parts of a computer, keyboard is a part of computer. Okay? So I cannot say that whatever the computer properties applicable to keyboard, this only part of it. Each will be having a different functionalities and the operating systems in it. Clear? Whereas all human beings will be having the properties of living being. And if I mention Karthikeyan will be having a property of human being. Or human being na idella irukonu I have set up. Okay, all those things will be there for Karthikeyan. In addition, he may have some other properties. Clear that? So is a not always instance of something. Part of abdina or whole part something alone we are considering. Next is association. This is completely different from other 2 things. Okay, so it is not part of it or it is not in the hierarchical order of something. It may be a relationship among 2 things. So I normally give an example as a author. Okay, the writer writes so many books. Similarly, a particular title can be authored by so many authors. When we take technical books itself, C or C++ or data structure, whatever the subject you take, C++ is written by so many authors. Similarly, that author might have written so many other books. So I cannot say this author belongs to that book or that book belongs to only this author, because C++ book is written by so many authors. So I cannot say C++ is an instance of only that author. Similarly, that author is an instance of other. It's not possible. So where I will be using association relations. Association relations. புரியுதுங்களா? When there are 2 things are there, between them when you are not able to define a correct relationship, this only gives this or this only gives this, then we go with the association. Okay, so I am the faculty of Cse department. I take class, though I belong to CSE, I take class for CSE as well as ECE. For me, both the students are equal. For me, CSE is higher and ECE is lower. In that case, it is an association relationship. Among the students, it is association. When I take hierarchy from the institution, management, principal, HOD, faculty, students. So there it forms a hierarchical relationship. Okay. So whenever hierarchy structure comes, normally instance. Okay. Whenever there is no hierarchy, we go with the association. Okay. So these 3 relationships you must know, because when you are generating the network, you must know. So these are the various components of again semantic network. In a components abhina, it's not like a hardware part. It's not a hardware part. It is about how we generate the semantic network. Okay. So you can just correlate with your IIT itself. In the beginning stage, what normally you are asked to do. First year, first semester, we form a team first. After formation of the team, you are asked to find out the problem statement. Correct? First step is problem statement, and at that time you will not be knowing how you are going to do. You only will be knowing what is the input of your problem, what is the output of your problem. And all the 5 are going to do. Right? Very basic steps when you are taking. What are all the like my network is going to have node, link, label. Only that much information I will be knowing in the lexical part of the semantic network. strings and labels. Only with that much information I will proceed. That is lexical part. Okay. When I initiate, like when you are going to write a program, when you are going to solve any problem, you write an algorithm. That algorithm can be implemented by any of the programming languages. Okay. Or when you start the project, you only divide so and so modules. But how are you going to implement each module is not the deal of your first step. First step will be only this many modules I am going to have. Similarly, in the semantic network, I am going to have node, link and labels. All are independent. I don't have any connection. I have not decided what is the node, what is the link. I only know I can have node, edges and label. Next step, what are all the nodes I am going to have? How I am going to have the edge between the nodes? That will be decided in the second part. So second part is more about how meanings, relationships and contexts are represented and interconnected. So it is beyond your lexical. I only would know only node, link, labels I can use. That's it. But here I could generate a basic network. Bob is greater than John. I have two nodes, Bob and John, which is being related by the edge and it is labeled with this greater than. Just very simple network I could generate in the second part, semantic part. Next comes to, there are, when I am talking about the relations, when I am talking about the semantic part, sometimes it may be non-appropriate, sometimes it will be appropriate. But when it comes to appropriate only, it will be of useful thing. So initially in my mind, or when I am drawing some graph, when I am constructing some graph, it may not be appropriate one. Later I will modify it and it becomes a appropriate. Example for a cube. For non-appropriate, I have two nodes that I got it from my second component, that is semantic part. I got it, Bob, John and the relation it is taller. But whether it is giving me the complete meaning now? No. It needs some more elements also to be added. And that is how I am adding H1 and H2 are other entities. Bob or height is entered here, John height is entered here, and then I am making a comparison among these two. When the height is not there, how do I measure that? Right? How do I decide this fellow is taller than other fellow? So when I give the first graph, it is becoming an inappropriate one. So I require some more additional information to go with the appropriate scheme. Clear? Next is very important, procedural part. So it is not like your lexical and semantic. It is more of I have constructed the basic network. Later on I may do some dynamic change on the network. For an example, your IAP itself you can consider. So initially your IAP is constructed by 5 members with 1 mentor. Okay, so you have 5 members in your team and 1 mentor is there. The network is done. After certain period of time, 1 fellow is leaving the team. He shifted to some other team, or for various reasons 1 fellow is removed from the team. So now your network is going to be altered. Okay, so 1 node has to be removed from that, and then the network has to be reconstructed. Clear? Suppose mentor is going to be changed. Mentor is going to be changed. Among all the members there will be association relation because all are equal. When the mentor is going to be changed, so that mentor has to be removed, new mentor has to be added, the mentor will be on top. From the mentor only, all others will be connected. But among the students, it will be of equal relationship. So this part, after the construction of the network and doing something dynamically, adding or deleting or modifying, or somebody's position may be changed, and again I am going to modify them. In a team, one must be a team leader, the rest of them have to report to them. So I am forming another hierarchy over there. All those things will be done in the procedural parts. How various activities can be conducted and how the nodes are modified or anything, any changes dynamically we are doing. That is done in the procedural part. Clear? Yeah, so here are few examples for you. John has a nose. It is a statement. Can we construct a semantic network for this? So each statement you will be constructing as a small network. Finally it will be combined. Okay, so it is focused on the centric of this. All the 5 statements starts with John. Okay, so John is one entity. Nose is another entity. Okay, 2 entities I have drawn for the first statement. John has a nose. John has a nose. Is it a instance or inheritance relation? It is only a property. Inheritance abina is a it should be an instance of so on. So here it is not an instance, so I can say it is a property. Okay? Fine. John is a person. John is a person. Now it is John is inherited from person, or John is an instance of person. You can use instead of is a, can be used instance also. John, instance of person. Next statement. John age is 30. So here I cannot connect. So age. So next is normally the numbers from number cannot be an entity. Number can be always changeable. Okay. So number cannot be entity because when I say age, suppose I am going to connect this network with some other network. Let's say Bob. Okay. So Bob age is 40. John age is 30. Like that I can use. Please remember, you may think John age is 30 now. Man 30 then you entity are no age is the label are no, not like that. Entity should be meaningful. Age. Number is always changeable. So that is the reason age is an entity. So here age, yeah, John age is 30. Clear? So next statement is person is a human being. Person is here. Okay. So is a human being. That one. So next is human being is a living being. Human being is a living being. So what you see here, John, from John next level is person. Person is human being is living being. Similarly, so if I ask you the successors of John, who are all the successors? Age, person, nose. I could see some hierarchy over here, right? I could see some hierarchy. So normally, semantic network will be able to give some structure for the statements. Appada, when it is generating the statements, it will be able to give some meaningful information. When you are giving a network, connect it. Appada, it will be able to relate to that and fetch the information and give you. Okay? For the same, okay, meaning should not be changed. Shape doesn't matter, meaning only matters. Okay, so here John, age, nose, person, human being, living being, all are entities. John is 30. John has nose. John is a person. Person is a human being. Human being is a living being. A sample or simple semantic network. Okay. Real-time examples. So semantic network is already being used on various word collection of words with their relationship. Okay, that is where finding out the synonym or antonym and all is done. Okay, for example, you are typing some word, instead of that word, I want to use some other words. It will give you a lot of words because it has the connection with so many other words, so it is able to give you. Or if it is in the form of a statement, you are asking, give me the same context with the different words. It will be able to relate and give you. Word net is only about the word. Concept net is based on the concept. And DB, PDR. Databasepedia, like we have Wikipedia. Wikipedia is for everything, but DBpedia is about one particular domain. Okay, so it may be about medical or education, or it may be of any particular domain. We can have the related content, so that from that it will fetch. And there are so many other examples also. Your ChatGPT, Copilot, everything are using semantic network. There also the real-time examples for semantic networks. Yeah, coming to the construction of this will be helpful for you to construct your own semantic network, and later for the implementation also it will be useful. So there are some steps. This is for us to understand. We studied about lexical part, semantic part, procedural part. Adala use panni whether we are able to construct the network abdina somewhere we find difficulty. That's why I am giving you the simplest few steps which are used to construct the semantic network. Step 1. You need to identify the domain and the purpose. For which domain I am going to do? Only one semantic network is enough to summarize everything now? No, it is not like that. Okay, so I can either talk about the student information or college information, or I can talk about the medical, or I can talk about the transport system, something. So for each and every domain, I need to have a separate semantic network. Okay, so I need to first plan or decide for which domain I am going to do and what purpose it is going to serve. Medical, whether it is about the medication part, or it is about the patient care, or it is about what? Okay, Ishita, what is your problem? Okay, so define the domain and the purpose. Step 2, entities. Identify the entities. Once my purpose is defined, domain is decided, it is going to be for the university management system is my domain. Then I need to look for who are all the entities of that. Okay, who are all, it may be the various departments, professors, various courses, students under that, they are all the entities of that particular domain. Okay, like that, after deciding your domain, you need to plan for the entities. Similarly, once entities are decided, like how we start doing it, who are all the entities, everything you will just spread it here and there. Here, these are all the entities. This is university, department, professor, courses, students, like that. Next step is I need to give a relationship among the entities. So when I say that the department could be like this, ECE and CSE. So I have to give a relationship among these two. Okay, so then under this CSE department I may have a professor, two professors may be there. Something. Okay, first I plan all the entities. Okay, நம்ம college எடுத்துறோம் அப்படினாக்கா, so it has three departments: CSE, ECE, IT. Okay, and then CSE has some number of faculties, ECE has some number of faculties, and then particular faculty is good at some subject, avங்களோட courses. Okay, so then when I look at our college semantic network, I'll be able to know about who is expert in Aiml, who is good at C or C++, something I will be able to understand from the network. Clear? So number 1, find the domain and purpose. Number 2, identify the entities, in other words, nodes. Number 3, determine the relationship among the entities. Step 4, establish the attributes. Like if at all you require any attributes. Of course, we need attributes for various nodes. Okay? So establish the attributes and create the network structure. So either network நம்ம சொல்ல முடியாது. This is not a network. Only nodes are there. So I have given edges like this. This is also not a complete network. Okay. So among all, if I am giving some relationship, then it becomes a network. Okay. So then, yeah, populate the network. These 3 steps are extension of it, but for the basic network, these 5 steps are enough. Okay. Once network is done, that network can be connected with other network. Okay. People, college total information will be connected with the university. Okay, so if the university connected over there. Suppose we are connected with PDKV. These two gets connected. Okay, all the colleges are connected to university, and these two colleges are connected together. Then how I am going to connect among the networks? Then visualize and navigate. So what are all the process I am going to do among that? Okay, so they want to, university wants to find the topper. Okay, topper among all the colleges. Okay, now, so all the data will be checked, and then they will be able to answer certain number of queries. So here the query is top 3 candidates of this particular academic year. So they will compare all the college results, and then they will be able to provide the top 3 or top 5 candidates amongst all. Finally, maintain and update. As I told you, as and when there are some changes on the entities or the edges that need to be updated as and when it happens. In your IAPT, one member is removed from that. Now one node has to be deleted, and the corresponding edge also has to be removed. Suppose a new member is added to the team, now node has to be added, the corresponding edges has to be constructed. Clear? That's about maintain and update. So with the first 5 steps, we are going to construct a network. Okay, after this. So here is an example. I don't think it is. Okay. Is it okay? Is it okay? Little clear? Mithun, read panna. You? Children, are you able to see this? Okay, so this is a sample network. One thing you must be very clear. Here the network is given. From the network, the system will be able to generate the statement. From the statement which comes to your mind, you should be able to construct the network. Okay. First, I will show you the reverse way. Then we will construct our own network. Okay. Fine. So the network is given here. Tom is colored brown. I can generate one statement. Tom is owned by action. Tom is an instance of dog. Dog is a mammal. Mammal has fur. Mammal has fur is a property, attribute. Mammal is an animal. Cat is an instance of animal. Tom caught cat. Dog sat on mat is a property or attribute. Dog likes bone. I think it's almost all relationship. But association, I couldn't show here. But in some scenario, we will be using even the association relationship. Okay, fine. So, what are the corresponding statement for this? Whatever I told you. Dog is a mammal. Tom caught cat, like that. If you are given the statement, you should be able to construct the network. That will be your exercise. Okay. Before that, I need to complete another topic. Yeah. Advantages. What are all the advantages from your understanding point of view? You can say. First point is about drawing a data. I'll show you then. Please provides a natural way to represent knowledge, reflecting how humans think about relationship between the concepts. You agree this? However, I think, okay, Tom is a dog. And apply I am able to represent by the semantic network. Tom caught cat. I am able to represent just by using some nodes and edges, and that is the advantage of semantic network. It's clear? Whatever I want to express, I am able to express it through my network with a simple representations. Flexibility. So you want to change the property like age. John age 30. After some time I want to like so John age is 30. John age after 1 year may be changed to 31. I created one network now that needs to be changed. That will be changed. Something will be changeable. Okay. So when you are a student now, after few years, you will be a graduate. You will be having your degree. Okay. So something can be changeable. That is possible with the semantic network. Suppose my network is comprised of only 5 nodes. After certain period of time, I am adding few nodes into that or removing few nodes into that, which is possible with my semantic network. Reason and inference. Yeah. Once the network is constructed, so here from the network you are asked to query what is the age of John. So my network will be able to answer it. Correct? Yes or no? So from this network I will be able to answer certain queries. So that's possible. Applications, yeah, NLP, because whatever comes to our mind only we are constructing it as a network. So it is applicable on a natural language processing, knowledge representation, expert system and cognitive modeling. So this expert system, you know very well about the expert system. Like expert system is always for a particular domain. It is not for everything, because I cannot say I am expert on all the fields. I may be expert on one particular field or only few fields. Okay, அதே மாதிரி தான் expert system may be only for certain domain, not for the whole thing. Okay, so that is where the semantic network beginning itself I told you. One semantic network cannot be utilized for all purpose. For one domain I can have only one semantic network. That is how it is used in expert systems. Okay, so cognitive modeling, you know how humans think and organize the way, timely response, situation based response are not possible to the human. So in the same way that will be able to do it. Next topic is about directed acyclic graph. So this is part of your semantic network only, because semantic network is a graph. Okay, graph is having node and edges. So here I have a direction between the nodes. John is a person, there is a direction. Person is a human being, there is a direction. Okay, so when two students or two departments are there, two department lab is there, CSE, ECE. You are told that ECE students as well as CSE students, whichever lab is free, you can make use of it. Okay, so CSE students may use ECE lab. ECE students are finding CSE lab is free, they are able to use. It is not that you தான் use பண்ணனும் அவங்க தான் யூஸ் பண்ணனும் கிடையாது. Both the way it is possible. Whenever this is free, they can avail. Whenever this is free, they can avail. Whenever bidirectionally it is going to be used or access I go undirected. But direction அப்படினா when there is a hierarchy, this can come only after that. Before that it cannot come, or it cannot go on bottom to top. Then we go with directed acyclic graph. Now coming to the definition, directed means the graph will be having a directed edge. What is the directed edge? The edge will be having a direction. Clear? Whenever the edge is having a direction, so here John is a person. I am not given person to John. புரியுதுங்களா? John is a person. All persons are not John. John is a person, but all persons are not John. So other way I cannot give the direction. So only display direction only is possible or meaningful. Okay? So direction must be there. And acyclic. What do you mean by cycle? Cyclic graph. What do you mean by cyclic graph? Starting and the end node of a path is same. Now we say it is the cycle. It is formed a cycle. There is a loop. Okay? So when there is a loop in a path, we say that it is cyclic. Okay? But here it must be acyclic. There should not be any cycle. There should not be the start and end node of a path is same. We say it is acyclic. Directed acyclic graph. So if a graph is directed and it doesn't support for forming a cycle, we say such graph as directed acyclic graph. Now look at the definition. A directed acyclic graph is a directed graph with no cycles. The meaning is that there are no paths that start and end at the same node, ensuring that the hierarchy structure is established. So here I could see some hierarchy. Suppose living being to John. Living being to John. So now what happens? It forms a cycle. Since it forms a cycle, there is no hierarchy. I will say that from John till the bottom to the credit. Again it is connected to this. There is no hierarchy over there. So that always ensures the hierarchy among the nodes. Clear? Properties will be there will be a direction and it must be acyclic. There should not be a cycle. So since there is a direction, it will be always one way. Okay? It can go on only one direction, not the other way. Then it will support for the hierarchical relationship. It addresses the hierarchical relationship. Yeah. What is the connection between DAG and semantic network? Why I will use DAG and semantic network? So whenever I want to use a hierarchical structure in my semantic network, I go with the DAG. There will be other requirement also where I don't have to use any hierarchy structure. If it is about institution information, it needs to be followed, yes. Or you are going to take some, you are going to construct a semantic network for the class. Okay, all the students of that class. So there won't be any hierarchy. Okay, so one may be good at something, other one may be good at something. You may be sharing the knowledge. That's fine. So there won't be any hierarchy. So wherever there is a hierarchy structure is required, only there I go with that. Okay, so DAGs are often used to represent hierarchical structure where concepts are organized in a tree-like structure or parent-child relationship. Parent-child relationship. Other way is not possible with parent-child, right? Parent has child. Okay. So, under parent or child, அப்படிதான் நம்ம அதை சொல்ல முடியும். Right? So, parent-child or a tree-like structure, opposite way is not possible. Child cannot be a parent and parent cannot be a child. Always, right? Fine. So, this is a sample diagram for that. Example, in the previous example, dog is a subclass of mammal, which in turn is a subclass of animal. But the other way is not possible. Okay. Right? Another example, detailed example for you. It may look like cycle, but it is not cycle. Right? You have to see the direction. When there is no direction, definitely there are some cycle. But it is a directed acyclic graph. There is no cycle. So when you are taking mammal as a centric focus here, mammal is an animal, bear is a mammal, cat is a mammal. Mammal has vertebra, cat has small graph. Where I am having that properties. Okay, so it can be of anything. So I have a semantic network where I have used that. The next type is undirected graph. Opposite of that. Okay, there only any direction. So it is undirected graph. When do I use undirected graph? When I don't want to follow any hierarchy. When I don't want to go with one direction. One directional flow I don't require. Other way also I want to use it. Okay, I don't want to use any parent-child relationship. I don't want to go with any tree-like structure. I go with undirected graph. Undirected graph. So undirected graph will not be having any direction, which means when I am having John has nose. But here if you see, CSE can go to ECE. ECE also can go to CSE. Okay, since there is no direction, I will be able to use it. I will take it in this manner. You don't have to use two lines. And maybe just one edge among these two. The meaning should be either this way or that way. So there is a symmetry among them. There is a symmetry. Okay, here we have max properties. A is equal to B. B is equal to A. According to the situation, we will be using. If requires to use B, we will be using it. When I say A is equal to B, B is equal to A, there is a mutuality. So there is a bidirection. I go with undirected graph. Now look at the definition. graph in which edges have no direction. There won't be any direction. The relationship between nodes is bidirectional, meaning the relationship goes both ways. Okay, it's not, whenever I say you have to share something, if I say both of you have to share, you have to give to other one has to give it to this one. That is what is undirected graph property. So they don't give it direction, and similarly if there is an edge between node A and B, then the relationship is the same as both the direction. A is equal to B is nothing but B is equal to A. A to B is nothing but B to A. There is a symmetry. Cycle presence. Yes, there is a possibility of forming a cycle. I'll show you one simple example. I have three nodes. Okay, A, B, C. These are the three nodes I am taking. When I am taking directed acyclic graph, okay, direction, just directed graph now. A to B, I have an edge. Okay, A to C, I have an edge. Suppose B to C. If I am having an edge, is there any cycle here? Is there any cycle? See, ma, the edge is established between A to B, one edge, B to C, other edge, A to C, other edge. With the three edges, with the directed graph, I don't have any cycle here. Okay? Suppose if it is undirected graph with the same edges, A to B, A to C, B to C, I could see an cycle. I cannot find any hierarchy over here. I cannot say who should come first, who will be last. But here it is possible, right? So do we see? I give you this way. There is some way out. Okay, but here it forms a cycle. How I am using in the semantic network. Of course, whenever you require hierarchy, go with only that. Whenever bidirectional communication is required, whenever this can fetch over there, that can fetch over here, both are equal, both are mutual, both are bidirectional, then I go with undirected graph. Used to represent relationship where the connections is mutual or bidirectional. So social network is an example. There is no hierarchy, right? Clear? I have given you sample graph already on the board. Same way I will give one more. So A is undirected one, B is directed one. So normally in the directed graph, we won't see any cycle. There is undirected on the same edge, same relation, there will be a cycle. Okay? Second example. Yeah. Comparison is very simple. Once you have understood about DAG and undirected, whatever the strength of DAG will become weakness of undirected. Whatever the weakness of DAG will become strength of undirected. Clear? Our strength in the weakness above the weakness in the strength of Mario. So DAG strength it is good for hierarchical data where there is parent-child relationship or one-way data flow. I go with the DAG. Okay. Second, it avoids cycle so that I will be able to maintain consistent hierarchy. Since there is no cycle and the hierarchy prompt. When there is a cycle, there won't be any hierarchy. Okay. So weakness, it is not suitable for representing bidirectional relationship. One way only is suitable. Bidirectional and DAG is not suitable. Apply reverse iron, undirected graph. Strength will be suitable for representing mutual relationship or bidirectional relationship. It allows cycle and multiple connection between nodes. Between the nodes, there can be multiple connection. Like in the network, you are studying network, right? So they will be sending a request, client will be sending a request to the server for some data transmission, and immediately server will be responding with an acknowledgement. Okay, and then it will initiate the data transmission. That and all we are seeing. Okay, so both of them, it is possible to have a connectivity, and they can have different kind of communications among them when it is not connected. Okay, fine. Weakness, it does not capture the hierarchical or one-way relationship. That will become minus over. It's time for you to know problem statement for today's session. Okay, so problem statements. The first problem statement I will explain you. Everything is same like the first one only. For all that you just need to construct a semantic network. So you need to construct it manually. Later it can be implemented. Okay, first manual formation vanduchna mattana that could be converted in Python. Okay, so here is the link. Or use mobile, scan QR code, download it, later you can use it.